Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 17, 2025, about 3 days ago. And this paper claims a scalable way to generate training data that sets a new state-of-the-art for instruction-based video editing. The paper is titled, Scaling Instruction-Based Video Editing with a High-Quality Synthetic Dataset. And as we'll see later, the results are really impressive. In short, the team builds Ditto to synthesize 1 million training triplets and then trains Editto with a curriculum, using an image editor, plus an in-context video generator, an efficient distilled model with a temporal enhancer, and an automated agent that writes and filters instructions. Also, the author shared a GitHub repo. You'll find the Ditto code with inference scripts, a comfy UI workflow, and setup files, plus models and examples folders. It includes step-by-step usage for diff-synth or comfy UI, instructions to download weights, sample prompts and test cases, and a simple infer script to run edits. Alright, Figure 1 illustrates what the synthetic pipeline delivers. Diverse, high-quality video edits that stay consistent across frames. Global versus local editing means whole scene restyling versus targeted changes to specific objects or regions. The left panel highlights global style shifts that transform the entire scene. In the center, structural reimagining preserves motion while reshaping content. On the right, local edits like object replacement and lighting tweaks remain stable over time, which is crucial for believable video. Alright, Figure 2 explains how the team mass-produces training triplets while keeping edits consistent across time. The workflow has 3 stages that clean videos, generate edits, and enhance quality, so the system scales without losing fidelity. The center engine uses an in-context video generator, meaning a model that follows a reference edit and depth-based motion cues to synthesize the full clip. The left panel deduplicates sources and filters motion. The right panel runs a vision language model filter and a light denoiser to remove artifacts without changing content. So Figure 2 explained the pipeline. Table 1 contrasts instruction-based datasets and shows that the new corpus pairs scale with real, curated footage. The hours row reports 1 million samples, which signals true breadth for training. It delivers high-definition clips at 1280 by 720, so edits remain detailed and readable. Unlike some prior sets, the data come from real videos and pass a filter, which means automated quality and safety screening before inclusion. So after Table 1 set the data scale, Figure 4 shows how the model learns to rely on text alone while keeping edits consistent over time. The pipeline starts with an edited reference frame plus the instruction, which pass through a text encoder and context blocks that guide the main diffusion blocks. Modality curriculum learning means the training gradually reduces, then drops the visual reference, so the network must follow text. A variational autoencoder compresses frames before editing and decodes the final video, ensuring stable generation. Okay, Table 2 shows that the proposed editor leads across both automated scores and human preferences, which means stronger instruction following with smoother motion. Clip text similarity reflects how well edits match the instruction, and the vision language model score is a learned judge that rates fidelity and quality. The automatic metrics block favors the new method consistently. The human evaluation block also places it first for edit accuracy, temporal consistency, and overall quality. Well, Table 2 ranked performance. Figure 5 shows why. The qualitative comparison, meaning side-by-side visual results, illustrates stronger instruction following and steadier motion because the rightmost column preserves layout while matching style or object changes. Style prompts like pixel art and Lego toy look crisp, and the clothing replacement stays consistent frame to frame. Figure 6 then presents a short strip where stylized clips translate back toward realistic footage, which signals useful sim to real transfer. Wrapping up, 2 takeaways stand out. A scalable synthetic pipeline can mint 1 million high-quality triplets, and with modality curriculum learning, the resulting editor follows instructions while keeping motion steady. The broader implication is accessible, safe video editing that generalizes, including sim-to-real transfer. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.